Hello everybody and welcome back to Advanced Maths. Today we're looking at the quadratic discriminant. You should be familiar with quadratic equations. ax squared plus bx plus c is equal to 0. And you should know that to solve quadratic equations, we use the quadratic formula. If you're not familiar with the quadratic formula, I will link my videos on this in the description below. The quadratic formula has a square root. It has square root of b squared minus 4ac. Now you cannot square root negative numbers. So if you try to square root b squared minus 4ac when b squared minus 4ac is less than 0, it will not work. You will get a maths error. So therefore, if you square root b squared minus 4ac and it's less than 0, you will get no solutions. It will not work. Whereas if you square root b squared minus 4c when it is equal to 0, you get one solution, because the square root of 0 is only 0, there's one answer. And then if you square root a number more than 0, for example if you square root 9, you get minus 3 and 3, you get two separate answers. And so your quadratic will give you two separate answers, two solutions. And that's when b squared minus 4ac is more than 0. This tells us a lot about quadratic equations. It tells us if there's no solutions to the quadratic, if there's one solution to the quadratic, or if there's two separate solutions to the quadratic. On a graph it looks like this. So if the discriminant is less than 0, it will never hit, the quadratic will never equal 0, and it will be above the axis. If there's one solution, it will have one root when it hits 0, and if the discriminant is more than 0, it will have two separate solutions like this. Let's see this in action. So find the discriminant for the following quadratic equations and state the nature of the roots of these equations. So the first one, x squared plus 6x plus 20 equals 0. We've got 1x squared plus 6x plus 20. A is 1, b is 6, and c is 20. Like this. We're going to substitute this into the discriminant, like this. And when we evaluate this discriminant using our calculator, we get minus 44, which is less than 0, and therefore there are no solutions. The equation cannot be solved. For the next one, let's move the 6x to the other side to make it equal to 0, as we do for quadratic equations, and we get 3x squared minus 6x plus 0, where a is 3, b is minus 6, and c is 0. Just notice that the number on the end is 0 there, and we substitute the numbers in like this. We evaluate and we get the discriminant is equal to 36, which is more than 0, hence the equation has two separate solutions and can be solved. Now the final equation, we've got a is 2, b is minus 8, and c is 8. We substitute those numbers into the discriminant, and we get the discriminant is equal to 0, and hence the quadratic has only one solution. Okay, so we know the nature of the quadratics. You may want to pause the video now and just try to solve those three original quadratic equations and check that they do indeed have no solutions, two solutions, or one solution. Okay, that will be a great way to convince you that the quadratic discriminant is indeed working as we expect it to. Now, example 2, find the set of values of k such that 2x squared plus 2 is equal to kx has exactly two distinct roots. Okay, this is a very interesting exam style question. Okay, so let's see this in action. We've got 2x squared plus 2 is equal to kx, and we want it to have two distinct roots. That language, two distinct roots, is kind of asking for the discriminant, because it reminds us of the discriminant language. Two distinct roots means the discriminant is more than 0. And so we're going to rearrange the quadratic to be equal to 0, and we're going to write that a is 2, b is minus k, and c is 2, and we substitute those numbers and letters into the discriminant like this. And we get that the discriminant is this, which we want to be more than 0. So let's find when the discriminant is equal to 0. And we solve that by rearranging and solving. We get k is equal to 4 or k is equal to minus 4. So the discriminant is equal to 0 at minus 4 and 4. But when is it above 0? Well, we can imagine this discriminant curve here, which I've graphed it like this. And it will be above 0 where I've highlighted it in yellow there. It will be above 0 for these values of k, where k is less than minus 4 or k is more than 4. Now notice that's the graph of the discriminant, not the graph of the original quadratic. And so I've graphed the discriminant quadratic, and I've seen whether the discriminant is more than 0 or less than 0. And it is more than 0 for values of k less than minus 4 or more than 4. And so we can say, therefore, the discriminant is positive for k is less than minus 4 and k is more than 4. And then for the original quadratic, 2x squared plus 2 is equal to kx has two separate solutions when k is minus 4 or k is more than 4. And we are finished. That example is quite conceptually difficult. I would advise you to rewatch my explanation a few times so you really get the idea of what I'm doing there. Okay? Now let's see example 3. Find the set of values of m such that y equals mx squared plus 3x minus 4 has solutions. Okay, so just to remind you, when the quadratic is more than 0, it has two solutions. When it's equal to 0, it's got one solution, and when it's less than 0, it has no solutions. And we want our quadratic to have solutions. So therefore either two solutions or one solution. We want it to be more than 0, or could also have it equal to 0. So we'll have our discriminant as b squared minus 4ac is more than or equal to 0. Okay, so a is equal to 3, a is equal to m, b is equal to 3, c is equal to minus 4, and we substitute those numbers in. We simplify and we make it equal to more than or equal to 0, and we get 9 is plus 16m is more than or equal to 0. We take 9 off both sides and we divide by 16. We get m is more than or equal to minus 9 over 16. So for values of m more than or equal to minus 9 over 16, the quadratic will have solutions. Okay, and we're done. So you've seen 3 examples of the discriminant in action. It's now time for you to have some practice. So complete the table of discriminants and the number of solutions in the green box, and then consider the quadratic in the orange box, and find the values of k where the quadratic has two separate solutions. Pause the video now and try this yourself. I'll reveal the answers in 3, 2, 1. Did you get it correct? Let me know how well you did in the description below, in the comments below. Thank you for watching this week's video from Advanced Maths. Remember to like and subscribe so you don't miss any future videos. We're covering GCSE, A-Level and IB Maths videos with quick and simple explanations, and new videos will be coming soon. Thanks for watching and good luck in your exams.